Well, hello and good afternoon, all of you grade sevens. And let me, as your facilitator and teacher for today, Mr. A.F. Gabriel, whom I think you know quite well now, welcome you to lesson 7 of Coding and Robotics, an exciting holiday program brought to you by the Department of Basic Education and Africa Teen Geeks. And this is all in the hopes of introducing you to a new curriculum that is straight away, as of 2021, being rolled out in a number of schools at all grade levels. And so we don't know whether any of your schools, any of you in the room today, may be fortunate enough to have this introduced into your schools, but it is coming soon. By 2022, coding and robotics will be moving even faster into our classrooms. And so you guys who have joined us here on the holiday program, you have a little bit of a heads up as to what we are doing, what's happening, and what it is all about. Okay, if you are new and you've joined us for the first time, welcome to you. We hope you enjoy the session with us today. It is very difficult to jump into coding and robotics in the second week. And I just want to say that if you have joined us, don't be put out. Maybe you're smart enough to catch up to what we're doing. However, all the previous 6 lessons are up on YouTube. So please see if you can find them and download them and watch them and experiment with them as we go along. And yeah, I'm sure you'll be able to catch up to what we're doing and then start coding as soon as you can. So all good. Let's begin with our class for today. Now, I just want to remind everybody, I gave you something to do yesterday. I gave you a race to do. I'm just going to, let me just get out of this presentation for now. We'll get back to it when we need to. All right, what you should be seeing on your screen is you should be seeing 2 cars. Now, yesterday I asked you guys to write some code which uses the random function, which I taught you yesterday. The whole idea of using the random feature in programming is called a random generator. I'm not sure if I mentioned that yesterday, but whenever you say you are using the random generator, it means you are using that random function. To quickly recap, if you look on your screen where my mouse is right now, you will see this oval shaped instruction, pick random 1 to 10, which is the instruction that uses the random function. Okay, so I know yesterday I had 2 cars. What I wasn't happy about afterwards, when the class was over, is that one car is a little bit bigger than the other one. And I thought that, if you don't set them quite right on the screen, the bigger car might have a bit of an advantage in the sense that it's got that little extra length. So maybe it's unfair and will win the race. So for today, just to demonstrate with you, I mean, if you got it working and it's fine, and look, who wins doesn't matter. What's important is that you manage to write the code. However, for today, I've got 2 cars that are of the same. I'm using the same sprite, so I know the size is going to be the same. Okay, now I have a question. And for now, I want everyone to answer on the chat, how many of you have managed to write the code to get the cars moving randomly? I'll just give everybody a chance to answer. And I'm just going to look at the chats to see if I've got any people. Look, I'm going to go through the code with you now. We'll write it up now so you can get it working. But remember, it's nice not also to just keep writing code that I give you. You've got to experiment yourself. Otherwise, kiddos, you'll never learn. So we do have some people, quite a few people are saying that they've managed to write up something. Somebody, they said they only got one car to work. Well, that's fine. I'm happy with that. Even if you've got code for one car to work, um, I'm happy with that. It's pretty good code. Hadia, welcome to you. You're saying that you were not here yesterday, so that's fine. I will try to go as slow as possible. However, there's so much new stuff that you pick up. It's not possible maybe to just catch up so quickly, but it's also like playing with Lego blocks. So try to follow, and we'll try to help you and support you, and I think you'll be okay. All right, Kwanga, welcome to you. You've got all the cars moving. I'm also going to add a few more cool things than just getting the cars moving. I think you're going to enjoy that. But let's go to the code, and I'm going to use the chat for you to help me. Right now, I do have the code for the second car. I'm going to show you quickly. Oh, so that I pulled it off pretty quickly. I don't want to waste time because the code for both the cars is actually the same. Okay. Now what I've already written the code for the second car, but I want us together through the chat. Help me now to write the code to give you an opportunity to be part of writing the code. And that lets me see also how many of you have actually learned anything in the last 6 lessons that you have been with me. Right, so here we are. We're in the script page, and we're going to write some code for car number 1. What do I do first? Help me, everybody, on the chat. When the green flag is clicked, says Libu saying, thank you very much. When the green flag is clicked, okay, first block done. Next. Okay, thank you, Sean. We got the green flag. What's next? Move 10 steps. Okay, let's go to motion and move 10 steps. Okay. Position. Oh, yeah, very clever. Right, thank you. Bongo Musa says, wait 1 second. Okay, I'll put the wait 1 second in there, and I'll attach it to the move thing. But I just want to go to what Lebo Singh said about position. You see, what we need to do is we need to position the cars on the screen before they start, so they both start at the same place, you see. Now, if you look where they are, and I'm going to kind of just do that for you, I am going to set a go-to first, you see. That's really what I want to start with, so that the cars start in the same spot, and I'm going to control that. I can't remember what I put for the first one, minus 160, all right? So I want to start at position minus 160, right? And let's start at a Y position. Let me just check where I started. 120. Okay, so if I start this car at, say, 150, let's run it and see where it starts. Right, can you see where it starts? 150. That's high up. Let's actually take it down. Let's take it down to 90, and let's run the code. It's still too close to the other car. Let's take it down to 40, and let's run the code. That puts it there. Right, that's okay. Man, let's take it a lot further down. Let's take it down to 10. There we go. I think that's kind of far enough, right? Can you see? I'll just keep running to test where the car goes, and it's like more or less starting at the beginning of the screen. Okay, now we want this car. This is the car we're working with. We want this car to move repeatedly, right? And it's going to stop when it reaches the end. How are we going to achieve that, everybody? Help? Combine the two. Yes, they are combined at the moment, but what else do we need to put around this block to get the car repeat? There we go. Sean, you're onto something. Repeat. So let me go to the controls. Here's all the repeat loops. Now, should I use repeat 10 or repeat until? Here we go. Smart people, repeat until. and we'll grab these two like this. Oop, I don't want them to separate. I want them to go into the repeat block. Here we go. And that's around the repeat block. So it will repeat those two moves. Right, now repeat until when? What shall go in our little hexagon shaped thing there? Remember we did this yesterday with the ball and the barrier. Sensing, excellent. I'll go to sensing, and Corbin is right. So hey, Corbin and Makweda, well done to both of you. Combined together, you gave me the correct answer. We're going to go to the sensing, and we want to see when it is touching the edge of the screen. Where on earth is that? Here we go. Repeat until touching, not the mouse pointer, touching the edge of the screen. Now this car will keep going, and let's attach that there, and it'll keep going until it touches the edge, and when it's going to wait, it's going to move at 1 second intervals. Too fast just to test. Let's just see if the car moves right. Okay, so run. And here we go. The car is moving. Eventually, it's going to touch the edge. Right. Now, here's the problem. If we move both the cars and write code for both the cars in which they move at 0.5 seconds, they will both move at exactly the same speed and reach the end. Can you see? There we go. It's reached the end of the screen and it has stopped. Okay, so that's pretty cool. It's moving until it's touching the edge. Now, but we want one car to be faster than the other one. How are we going to do that? Obviously, we need to use this random function. Now, help me, class. Where shall I put the random function? Are we thinking? At the wait, right? We can put it at the move as well, right? But I prefer to do it here. Now, this is great. Now we're saying pick a random number from 1 to 10. Now we have to change that because 1 to 10 is 1 to 10 seconds. You're not going to wait 10 seconds while the car moves 10 steps. That whole program could take a few minutes boring. So we have to change to put some decimal numbers in there. Now, I said to you, my daughter's in grade 7, and I do apologize because I teach high school, and I wasn't too sure. Only after yesterday's class, I started wondering whether the students in my class are quite familiar with decimal numbers. Now, she assured me that, well, they first introduced you to the idea of a decimal point in grade 4. So I think by grade 7, you guys are quite familiar with the idea of a decimal number. And you realize that the more zeros, let's put a number in here, like for example, 0.05. The more zeros you have in front after the decimal, the smaller and smaller the number gets. Right, so let's run it from 0.05 seconds to, let's see, 0.5 seconds. Let's see how that goes, right? Let's test it, run. That's kind of like an okay speed for it to move. Let's test it again. It'll choose a different speeds and keep moving. How's that for the race? That's kind of okay. Are you happy with that? And it hits the end. There we go. Now let's have a look at the code for the second car that I already had written up there. Pretty much. Okay, let me just take this out. That's something that I added there. Okay. Right, let me get to I'll talk to you about this little block that I put in there. Right, now we want them both to start at the same spot, minus 160. So that's good. This one is also starting at minus 160, right? And when the flag is clicked, it's got to do that and repeat until touching the edge. That's our second flag, and there both cars are going, right? Okay, and the first car gets there, right? And then the second car gets there. Right now, I put different randoms in there in the second car. Let me change those numbers to be the same as we put in the other car, and let's see what happens. Let's let them both race now. Okay, there we go. They're racing, and it's looking good. So at least it's not such a obvious win. And car number 2 wins. Let's race again and see what happens. And it's That's the first car. Have I got the times right? Okay, look, and that's pretty cool. And that car stops. Okay, so let's just check our code. Repeat until touching edge. Repeat until touching edge. 10 steps, 0,05 to 0,5. Okay, yeah. So one car is winning the race. So that's sorted out. We got both the cars moving. Well done to everyone. You can all give yourselves a good clap. Now here comes the big trick. How do we decide? How do we decide which car wins? Which car wins? Hmm. Okay. So, and here's the clue. Let's use the costumes. Let's use the costumes. Right, let's go into our costumes. Let's see which car we got highlighted first. Right. Okay. We have to do this code for both the cars, right? And they both were our starting positions were the same, so that's pretty cool. Right. Let's go to car number one, and let's go to his costume, and let's say looks, and say switch to costume convertible 2. I have no idea why they didn't call it 1. When you go into the costume, you'll find that this car here has only one costume, right? I added a second costume to my car, convertible 2, to this one, the first one, and you'll see that it is I win. When you go to the code, all I did was I added I win. I'm going to show you with the other car how to do that. So let's go back to the code, and let's go, and I need to see which car did I do that with. Right, so car number one, right? Car number one, which is where we are writing the code. This is car number one's code. So we switch to costume 2, and when he gets to the edge, we will switch to the other costume whose name was well, no, sorry, that's costume 2. The normal costume is convertible 3. Sorry, so we have to change that. That has to be convertible 3. And if the car wins, we will change its costume to this one, which says I win. And it is, look at where I'm pointing, it's actually costume number 2, right? So normal convertible is cost convertible number 3, and convertible number 2. Sorry about the numbering, guys, but I think you can manage. Right, so that's only this first car. So this will happen only if this car wins the race. Okay, and the second car is winning, and they both seem to be almost getting there at the same point. Right, and the second car, now the first car got there first, but this car is saying I win, because eventually, when is it going to say I win? When it is touching the edge, right? Now let's add that same code to the other car. Let's switch its costume to convertible 3. Let's see, right, that's convertible 3, that's its normal costume. And now we have to create another costume. So how do we do that? Right, follow my steps. You go first, you click on costumes, and then you go to the costume, right click on the costume that is already there, and you click duplicate. It will make another costume for you, right? So there's costume number 3. It created another exact copy of this costume, and it is costume number 2. Now we want to just write I win there. So can you see when you're editing this thing? Remember I said you can make changes to it. I'm going to just click on the text editor there, right? And then when you've got the T highlighted, it means you want to add text. Can you see? It says text, and click somewhere not too close to the car, and it gives you a space where you can add some text. That's the color of the text. You can change the text color if you don't like that purple color. You can change the hue of it. Let's make it red if you want it really dark red, and that's kind of okay. And it says I win, and that's that. And it is now saved in there as convertible number 2. So let's go back to our code. And if he gets to the edge, we want to say switch costume to convertible number 2. And he will say, I win in red. Now let's run the race. Okay. Oh, they both pretty much seem to be traveling almost at the same speed. And now they're both saying I win. Okay, very interesting. I think what I want to do with this one is let's also change this costume's color. Change color by 25 so we can actually see the difference in the two, right? So I've added a change color block after the costume. Let's run it, and you'll see that car is a different color now. Ooh, he's really going fast. He's gotten ahead there. Okay, and then the second guy came up and he says I win, and then this one says I win. Now that's wrong, right? Both the cars cannot win the race. Only the one that gets to the edge first is going to win the race. But we are actually letting both the cars continue moving until they reach the edge, which means what we have to do is that we are going to have to stop the cars or stop everything when the cars get to the end. So what we are going to do is we are going to stop everything. We want the race to end when one of the cars wins the race. So now I'm going to teach you something new that we are going to add. So when the cars stop, and that is this thing. And I wanted to teach you this control called stop all. Have a look at this one, right? That is to stop everything. So as soon as a car wins, we want you to display its win, and then we want the program to stop. Now we need to go to the second car, and we need to do that for this car as well. So let's look at car number, this is car number 1, this is car number 2. I got a whole lot of bits and pieces here that I'm trying to save time. I'm going to show you all these things later, but just worry about the code that's out here. Right, so the only difference between the two cars now is that this car is changing its color. So they're both not green. It means it's a bit easier to see the difference between the two cars. Now let's run the code. And they're going for it, guys. And anybody want to do some commentary? And the green car's out in the front now, and the blue car's catching up slowly. And well, the red car wins. Well, the first car wins because of the all stop. Its costume has gone back to green. Can you see the second car is very close? Came in very close. Is not touching. And now here you go. You've got it perfectly done. A race, and you only showing one car that's going to win the race. Let's just do it again and see whether that first car is going to win again. Oh, looks like he really is going to win again. And I win. Oh, let's just see if that second car ever is going to win a race. Doesn't look like his random function is. Oh, that first car is always just winning. Okay, so which is that first car? The one that changes color. All right, let's go to the second car. And let's make him a little bit faster. And how can we do that? We can give him much faster time. Instead of letting him possibly choose 0.5, let him choose 0.4. And instead of 0.05, let him start possibly at 0.06 and see if that helps to, oh, look at that. That's giving him a bit of an edge. He's a faster car. Nobody knows it. And the second car hits the thing and says, I win. And as you can see, everything stopped, and he's had a chance to win. And let's have a look at our code. Okay, so we put the original costume. They both start at the same spot, minus 60, 10. This one is minus 6120. Remember, this is the Y value. We want him to be lower, but the X value is the same because the X value is left or right. We want them both to start at exactly the same spot. So they're both starting at an X value of 160, minus 160. I chose that because if you look at it, it's very much close to the edge of the screen. You can't start the car there because you remember you have a repeat until touching edge. And if you go too far to the edge, it's already touching. Remember, this is also an edge. So saying repeat until touching edge, the car won't move at all, right? So that's pretty something to remember. You can't start them off and get a little bit more distance for yourself from there. Okay, so yeah, that's the car race, and then that's pretty much going. And I'm going to do a couple more things with the cars and the random feature for today. But in the event that we are okay, so um, everybody, um, let's see if there are any questions. Okay, now some people are saying that you have no sound. Can everybody hear me? And can everybody see my screen? Okay. Okay, that's good. Are there any questions about this car race? We're still going to fiddle around. Okay, good. I think maybe some people just may be having problems. Ndovo says you can't hear me. I think the problem might be on your end. I'm unmuted and everybody is with me. Hadia, you said go slow. Okay, I'm going as slow as I can. However, guess what? You can download this video and then you can watch it and pause so that you can experiment with the blocks. Okay, now everybody, um, are you all good? Can I go to the next thing? Um, okay, now watch this. As soon as we start, the race starts. So that's not normally what happens. Normally we have some kind of flag or something that gets waved, We should control when the race should start. So I am going to add, that's what I had this piece here for. I had a wait option, which I think we can put it anywhere, but let's put it right at the beginning. Let's get the cars all ready. Let's get it changed color and everything. And it says wait until. It's not a loop. It's a single block of code. Can you see? It's not a loop. It's not a repeat where it's grabbing other blocks of code. It's a simple wait until instruction. So we're saying wait until something happens. So the program, when it gets here, the sensor will take over and it will wait until this blue um, elongated hexagon is ready. And what is it saying? It's saying wait until the key space is pressed. So in other words, in this scenario, our race will only begin when we press the space. Now, both the cars have to have that code in as well. Otherwise, only one car will get going. And it was here. Wait until I had it here. And wait until the key space is pressed, right? I drag a hexagon and can you see it's highlighted? You wait until the block is highlighted and you let go and it's now ready to start. Now watch what happens when I press play. Okay. Something is not right with our second car. Okay, I put the weight in the wrong. Can you see the mistake I made there? This car hasn't gotten to its starting spot yet because I've got the weight instruction before that. So I need to fix that. Let's take this block out and let's remove that one. And that goes there and the go to first. There you go. Right now, can you see how you fix things? Again, you can grab blocks of code and separate them like Lego blocks, right? If you're grabbing blocks, and I did this already, but I'm repeating. Some people are new today. Wherever you press the grab, it'll grab that whole block of code, but you can only separate code from the bottom. Watch, I'll do it again here. You cannot separate code by thinking, let's pick this up off the top, right? So it's not going to go off the top. It's not going to grab these three things and pick them up. It's going to take from change and separate from there. So if you want to insert things, sometimes you might have to make gaps. So I wanted to put something in there So I created the gap there, right? And now I rearrange it. Now when I press the flag, voila, look at that. Both the cars are ready to go. And now it's waiting for me to press the space. So you can't see me pressing the space, but I'll try to press it hard enough to make a sound, and you will see the cars will start. Okay, and here they go. All right, that blue one is pretty slow today, and I win. Now the race only starts when you um, press the space bar. Okay, so we can decide when the race should begin. Now, guys, few problems. How does remember I taught you the person who's using the computer program is called the user. How does the user know? How does the user know? I'm going to drag those out. That he has to press the space bar. Right? See, like here, he doesn't know at all. Okay. Is there anything we could do to solve that problem? We could do all sorts of things. We can put a robot sprite that changes to green and then make that sprite disappear from the screen so that they start. But maybe we just want to tell the user to please press the space bar to begin the race. Okay. Right, but we'll add all those things as we go along. Right, so I think we're all happy. We can see that the cars are moving. We have actually made this second car, this one, faster than that one because we have given it a smaller possible numbers to choose from for its weight. So if you look at this convertible, this car here, it races from 0.06 to 0.4. It will not choose 0.5. So it's likely to win the race. This is the car on the top. So this car at the bottom here is the green car. It's going to go faster because 0.5 is a longer delay than 0.4. So the other car can choose 0.5, and when it chooses that, it obviously is going to make a longer delay before its next speed. All right, time is going, as they say, and I want to go on to the next thing that we're going to do now, and I'm going to show you how we're going to even improve this racing cars. But let me save this project, right? Let's call it racing. Oh, I got my caps lock on. Racing car. Again, for those of you who just joined us, if you want to save any of the code that you were working, remember you were working online in a zero-rated platform, but you can save all your code to your computer where you can have it for yourself. To do that, in this white space, you click there and you name your project. Right now, this code, 2 sets of code, remember each sprite has its own code, all of that will both get saved together using this project named Racing Car. I go to File and I go to Save to your computer, and you will see from the online platform, look on the bottom left on your screen, it's saved that project now as Racing Car. Stop flashing, so that means it's properly saved. Okay, now here's our problem that we want to comment on this program. You see this repeat loop here, everybody watch. It keeps running and moving 10 steps until it touches the edge, but it never moves at the same. In fact, this car is not moving at the same speed. Its random function is picking a different weight position for each of its moves. So it might move fast, and then it might move slow, or fast, or slow, and maybe we want the cars to have a constant speed at which they are moving. And then the race would look so it doesn't just keep picking a different number every time. We just want to give it a single delay. We won't know what delay the computer chose because the computer will still pick randomly, but we will watch as the cars race. Now, let's take the random feature out to show you what I'm talking about. Let's make this car constantly move at 0.5. That's the first car. And let's make the second car constantly move at 0.4. So the second car should win the race because it's moving at a slower delay. And let's see what this race looks like. We need to press the space bar to get them to start. So you can see now it's always using the delay of 0.4, not using different, randomly different things. And eventually the car with the 0.4, which is the one on the top, it will eventually win the race. But the delay is the same. It's 0.4 throughout. It's not continuously changing its delay. And that will be a better way to run the race, so that it, then we know exactly whichever car chooses the smaller, or the smaller weight delay, that car will eventually be the winner. But it still has to randomly pick that figure, right? It still has to randomly pick that figure. And how do we get it to only pick one thing? Okay, the answer to that is this. We have to use something called a variable. Ooh, what is that? Okay, right. Now, I'm going to have to go into a slide presentation, um, to teach you that. So I'm going to just drop that, and I'm going to open this PowerPoint presentation that I had running, and I'm going to run it from the beginning, and you can see that. Okay, and now we're going to actually enter in officially into lesson 7, which we will continue with tomorrow. And I'm going to introduce you to this idea of using a variable, right? A variable. Now, where is the variables? The variables are, sorry, there is a variable tab. There is a variable section of coding. When we go back to MS Zora, I will show you where that is. We might just manage to do that in the 20 minutes that we got left. But I want you to think about this. In the program that we have been working with so far, you will find that the user has done nothing but look and watch. In the last car program, we gave him some control. He can at least press the space bar to start the race, right? But if you look at all the programs we wrote before, with the ball that's bouncing on the screen and the little robot moving forward on that nice cloudy thing, or even the ballerina that was jumping up and down, what is the user doing in all that time? He just sits there and he watches the program happen. Now, what use is a program that is just, well, all you do is sit there and watch and don't interact with it, right? At least with this car program, where I added this space bar, the user knows that he has to press the space bar to start the race. At least he's doing something. But then after the space bar is pressed, he doesn't do anything. He just simply watches the cars go, and then something wins. Eventually, you're going to get very bored with a program like that. The user cannot interact with the program. Now, how can we get the user to interact with the program? That brings us to a concept that I must teach you. Yes, variables are part of that. I'll tell you what that is first, but I must first explain to you this process called IPO. Can you see at the top of my heading, lesson 7, IPO, I-P-O. What is IPO? Does anybody know what IPO is? And no, let us show you what IPO is. Okay. IPO is actually not a word of its own. It stands for something. The I stands for something, the P stands for something, and the O stands for something. I for input, P for process, O for output. Okay, now let's go back. Input. What is input? Does anybody know? What is input? If anybody wants to answer, you can answer on the chat. Does that word seem strange to you? Have you heard it before? Input. Right. Okay. I'll answer it for you. Input is when a computer program is waiting for information or data to be received from the user. So whenever the user interacts with the program, the computer would refer to that as input. Now, input can come from a number of other sources, not just the user interacting. If maybe some information or data can be stored in some small file or program that can be loaded at the right time. But in coding and with the robotics, that's not so much what we end up doing. The user wants to interact with the robot straight away. You want to give instructions and you want to see the robot follow your instructions straight away. So when you press buttons or do things or move in certain, make it move in directions, you want to see it going straight away. And that is referred to as input. So you notice that our programs, they haven't had any input. They program to just, the sprites just do what the programmers tell them to do. The user can't do anything. Imagine if we can get the user to press buttons on the keyboard and those buttons cause the sprite to do something. Pretty exciting. And that is really what we refer to as input in this coding and robotics idea. So we are talking about the user pressing buttons on the keyboard or using the mouse, and the information travels to the computer and eventually to our sprite. Okay, so then what is process? Well, if you give input, the computer has to process that input. It has to say, okay, now what did the user press? How does it know what button you pressed? Secondly, how does it know what to do when that button is pressed? All of the code in the program that makes the sprite do what we tell it to do is called the process. Who's in charge of the process? The programmer. You and I, the people who are instructing the sprite to do things, where all our algorithmic instructions are, that is referred to as the process. And then, of course, the program will have output. Once it processes our instructions, something happens. Maybe our instruction might make the sprite move. The sprite actually moving on the screen is called output. So IPO is the full principle of coding. We put stuff in, the computer processes what you put in, and then it gives you output. In other words, you will see something happen based on what you did. That is the IPO process. Now, a computer program without input is simply following processes that were pre-programmed by the programmer and outputting results from that process. The user feels kind of left out. So the input part of the programming is when we start to include the user in what we are doing. So we get some input for him. Now, we're going to add, our program so far have had P, where we have written instructions for our sprites, and our sprites have followed our instructions, and they have been giving output. But the user has been completely and utterly left out because he has given no input. And we're going to change that, and we're going to include some variables in our program. Now, some ways that users can input is through the use of a variable. Remember, if we are going to let him press a button or do anything on the keyboard, we're going to have to find out what he did. And how are we going to do that, right? We are going to have to store the button he pressed. So if we tell the user, right, press the space bar to do this, okay, we've got the sensor there, but that's completely different now. We want to actually give some instructions to the user and say to the user, if you do this, the sprite will do this. If you do a different thing, or if you press a different button on the keyboard, the sprite will do something else. But in order for us, remember, it's artificial intelligence. The sprite doesn't know what the user is pressing. We do it. We are the programmer. We are the masters. We're going to say, oh, he pressed this, so we'll make the sprite do that. So we do everything. We have to control it. So how do we do that? By using a thing called a variable. So the big question is, what on earth, sir, is a variable? And here is the answer. A variable is used to store information, input that the user of our program enters. So can you see that? That's what a variable is. So we're going to say to the user, yeah, press this button or do this. But in order for us to know what he has pressed, we are going to have to store it. We're going to have to, another word for store is save it. We're going to have to save it in the program and keep it there. And then we're going to have to find out what he pressed. That's going to be cool too. All right. So it's getting a bit more intricate now, right? How can the user enter anything? You can enter it using the mouse or the keyboard, which is most common, and it's a bit complex to use the mouse. So we'll start with using the keyboard. It's an easier device to get input from. Most of our computers use either a mouse or a keyboard for the user to interact with the computer. But some people have other things, like you'll see I listed some other devices. Remember, any electronic component that can be bought and added to a computer is called an electronic device. So any device that can be used for input is called an input device. So our mouse is an input device. Our computer keyboard is an input device. But we can have other things. Like, for example, if you buy this thing called a joystick and plug it up to a computer, you have instead of pressing buttons or using the mouse to move things around, and you've all seen a joystick, you can put your hand on the joystick and you can control left, right, up, down. Pretty good for gaming. A touch screen is also an input device because, on your phone, not so much computers, but some of the new computers, the screen is a touch screen, which means you can put your finger on the sprite. Imagine that. You can put your finger on the sprite and get it to move left or right. I think lots of you have played many interactive games on your mobile device or your tablet, or if you haven't got one of your own, maybe one of your parents. And you'll find that most of the time, you've got to put your finger on the screen. Sometimes you can tilt the device to get it to do things, but you put your finger on the screen and interact with the program, right? Touchscreen interaction is a lot more complex to program and code, and you are only in your 7th lesson of coding. And you've done lots of good things if you look at all that I've taught you so far. But operating a touchscreen is not very simple, and we've got to, as they say, that old expression, we must walk before we can run. So let's practice first with using the keyboard, and then maybe we can progress to the mouse, and then maybe you can use the touch screen. So that's a variable and how we're going to capture data from the variable. Right. Now we want to create a variable in MS Zora, and we're going to do that. We might just have time to create one. But how do we do it? Now, here is the process. I'm going to go through the instructions first. Unfortunately, I can't have MS Zora and the slide presentation open at the same time on the screen. So I'm going to finish this presentation first, and then we'll jump into MS Zora, and we will do the variable. I'm going to just go through the slides, and the reason I'm going to do that is so that when you download the video, the slide presentation would get saved as part of that video, and you can pause it on this if you're going to forget how to create a variable. So step 1, click on the variables instruction group. Step 2, click on make a variable. A dialog box will pop up. Step 3, give the variable a name. Step 4, choose if the variable is going to be used for all sprites or only for one sprite. And step 5, click OK. And your variable is and will be created. Okay, now, remember, let's go back to this. You might be wondering this. Give the variable a name. Step 3. You might be asking this question now, what names can you use? For example, can I call a variable by my name? Gabriel. Trevor, I see you in there. Can you call your variable Trevor? How long can it be? Can I call it? I don't know if any of you watched Mary Poppins, the old one. There's a very, very exciting word in there. The word is supercalifragilisticexpialidocious. Can I call a variable supercalifragilisticexpialidocious. I wonder if any of you could spell that. Tomorrow's homework, find out how to spell supercalifragilisticexpialidocious. Next question. If you spell it correctly, how many letters are there? Good question. Okay, now, I want to skip to this one. Naming variables. Okay, so how do we name a variable? MS Aura does not have rules for naming variables, which is pretty bad. You can pretty much name it anything, right? So, but I'm going to teach you some rules that I want you to follow, because when you do move to high school and you change to Python and other languages, most languages do have rules. There are things that you can do and can't do. There are also things that you should not do, even though the program will allow it. Later on, you will see when you want to do some complex things, your variable name will get in the way and mess your stuff up. So yes, although you can name a variable supercalifragilisticexpialidocious, it's too long. One of the things we would advise you is don't choose long names, because you're going to have to type that name out whenever you're writing code. So your code is going to get long just because the name is so long. So keep it small, under 10 characters is pretty much fine. Okay, so I'm suggesting that we apply the following rules for naming variables. And let's go. Naming rule number 1. Start your name with a letter, not a number or symbol. Remember, symbols we talked about yesterday, they are all the symbols that are on the number keys on your keyboard, right? Don't use any of them. Second, you can use a symbol in your name, but don't start with that, right? So, for example, you can call a variable n1, but you can't call it 1n, right? Don't start with a number. Next, don't put any spaces, right? Don't put somebody, I'm laughing because somebody on the chat has spelled supercalifragilisticexpialidocious, and well done. You're actually, you guys are funny. You're making me laugh. Well done. You're humorous. You're actually right. I know how to spell that word because I've watched Mary Poppins tons of times when my kids were small. I had to sit and watch that movie every day for months. So thank you, guys. Well done. Right. So anyway, let's get back to our lesson now. Let's focus. Don't use spaces. Avoid the symbols. I know that looks a little bit crooked there, but you can use the underscore. Right. The underscore is not a dash. Can you see it's on the line? The dash is in the middle of the line. Where is the underscore? If you look on your keyboard next to the button 0, which has got the close bracket, the underscore is sharing with the dash sign. You'll see the dash sign. Then you'll see on the top there another line that's much longer than the dash line, right? Everybody, look on your keyboard. If you're using a phone or a tablet, you won't have a keyboard. But when you do activate your tablet's keyboard, have a look at that. Right? That is called the underscore. That is a nice symbol to use when you're naming variables. And lastly, the name should give you an idea what the variable is for. So again, we won't use variables using our name. Alistair 1, Trevor 1, Lebocang 2, Corbin 3. I mean, really, what are we doing in the program? Maybe because our car is racing, maybe car 1 might be a nice variable name. Or since we're going to use a variable to control the speed of the car, why don't we call our variable speed or car speed or things like that? So we're going to go in and we are going to name some variables, okay? But we don't have a lot of time. We have 7 minutes, and I'm going to now get out of that presentation, and let's close up that presentation and let's go back to our MS Aura Blocks program. Here we are, and we are back in. Hello, and thank you for your patience. Okay, now we want to use a variable, right? Okay, so let's go to the variables. Okay, if you click on the variable section of the code, you will see there are variables. Now, MS Aura has 2 ways of working with input from the user, and one is actually in the sensing. Let me just see if it's there. Yes, it's in the sensing, right? If you just want to do simple interaction with the user, one way of doing that is by using the ask block. For example, you can ask the user, what is your name? Do you see it says, ask, what is your name? And wait. Okay. And then we will, what do we need to do after that? Right? After we do the ask, okay, you guys are writing all sorts of funny things in the chat. Come on, I want you to focus on ask, right? All right, good. You haven't seen this before. You select this block here, ask and answer. You see that? It's an ask and answer block. So it's built in. Okay, so that's one way of doing things. But if you want to use a variable, and we'll demonstrate these things, I'm trying to get everything done. So let's take the ask and answer out. We'll demonstrate it to you when I get a chance. Let's go to our variables. Right, I just quickly want to go through the process of creating a variable, right? Right, so the process was click on make a variable, and you'll see it says a dialog box opens, and this is where you have to give your variable a name. So before we close today, I just want to do things, show this because I couldn't do it in the slides. This is not a very good name because we said don't start with a number. This might be a good name, right? And you can use the underscore. I'm going to show you now. I'm pressing shift and I'm pressing the dash, and it uses the underscore. The underscore is nice because it separates things. So can you see? Num1. Let's call this variable car speed. I'm also using the same capital letters for each new word. This is my preferred way. I don't use underscores. Lots of programmers like it. I find it irritating in the code, but I gave you some rules which you can follow. You don't have to use what I use. This is called camel case, but it's better. I kind of prefer, right? Then you click OK, and your variable is created. Okay. Okay. This is the other one that was there from the answer one that I had not put off. Let me, where's that? Sensing. Right. Take that out. Right. Okay. Now, as you can see, it's created a variable. And you see this tick there? Right? So you've got a variable, and variables are saved as oval things. So they can go in all the spaces where the ovals can go, right? Now, if you look before, we only had all these things. You've created a new variable called car speed, and all the variable blocks have included your variable. So you can make use of that variable, okay? So that's how you create one, and that's how you name one. Now, we haven't got any more time to include that variable into the car race, so we're definitely going to do that tomorrow. Proper use of variables, and we're going to use this variable to control the speed of the car. If you want to fiddle and experiment and try to do it by yourself, hey guys, knock yourself out, have some fun. But I'm going to officially show everybody how we can control the speed of the car by introducing a variable into the mix. Okay, and that will have to be for tomorrow, right? So for now, we are almost out of time. I've got 1 minute. I'm happy to answer any questions. If anybody would want to answer anything, I'm sorry, ask me anything. I can take one more question. Trevor, you've got a question. All right, I'm gonna unmute you, Trevor. Ask your question, Trevor. You are live.
Okay. So, is it true that you can add other cars to race with?
Yes. Well done. You can. I mean, we just put 2 cars, but you can add 3, 4, 5. Well, you can see the stage isn't very big, so I don't know how many cars you think you can squeeze in. But yes, you can add 3 or 4 more cars and race them. So I think you pretty much you can try that if you like. Thank you for your question, Trevor. All right, I'll take one more question from Hadia.
How do
Okay.
you record the lessons?
I'm not
How do
sure.
you
I'm not sure if you can from your side. There is a feature with Zoom that has record. The shortcut for it is Alt R. You try pressing the Alt and the R from your keyboard and see if it'll record to your computer. However, you can download this video from YouTube. Okay, so guys, it's 2 o'clock. I am out of time. Once again, thank you for joining me today. I hope I see all of you, even the new ones, again in tomorrow's lesson as we introduce you to a variable. You'll see now our animation can take on much more exciting things, very, very powerful stuff to come when we're going to have the user controlling things on the screen, all because we're going to be able to use variables. So thank you again for being with me today from the Department of Education and Africa Teen Geeks. Have a very good Tuesday afternoon.
Bye.